Hello everybody, I'm Dr. Luigi Vorluni. Welcome to this lesson about stereochemistry of nucleophilic substitution reactions. These organic reactions are a very important topic in A-levels chemistry. There are two types of nucleophilic substitution reactions, SN2 and SN1 respectively. SN2 are discussed in this video, while SN1 will be discussed in a separate video. A nucleophilic substitution involves the replacement of an halogen, such as chlorine, with a nucleophile, such as hydroxide. A nucleophile is an electron-rich atom, molecule or ion that is attracted by and can donate a pair of electrons to a positively charged center, such as carbon, to form a chemical bond. There are two types of nucleophilic substitutions, SN2 and SN1 respectively. The second order, or SN2, means that the rate of reaction depends on both the concentration of the nucleophile and the concentration of the halogenoalkane, while the first order, or SN1, the rate of reaction depends only on the concentration of the halogenoalkane. This difference is determined by the underlying mechanisms of reaction, and those related to SN2 will be discussed in this video. I have simplified the graphics and concepts to facilitate understanding. We will see the different aspects of the chemical reactions with a progression from simple to more complex, because this helps learning. This is a simplified version of SN2 chemical reaction, and I am using the analogy of the jigsaw puzzle. I am illustrating only carbon, chlorine and hydroxide because they are more directly involved in the reaction, and for now I want you to focus on just the dynamics of the action. As you can see here, hydroxide bonds to carbon and at the same time chlorine bond breaks. In other words, hydroxide attaches and chlorine detaches simultaneously. Now let's see SN2 in more details. I have included carbon, chlorine and hydroxide, but not the other compounds, in order to simplify. When a halogen such as chlorine attaches to carbon, they form a polar bond, because the halogen is more electronegative and attracts the electrons closer to itself, thus becomes slightly negatively charged. In other words, is more electron dense. Consequently, carbon has lost some electron density and becomes slightly positively charged, and this makes the molecule more susceptible to attach to a nucleophile, because a nucleophile has a lone pair of electrons in the outer shell that can donate towards the slightly positive center to form a new covalent bond. There is a number of nucleophiles, and the one often illustrated is hydroxide, which in the outer shell of oxygen has got a lone pair of electrons that can be shared with carbon. At the start of the reaction, these electrons are attracted to carbon to form a new bond. As we can see in the transition state, the bond between hydroxide and carbon is forming, while the bond between carbon and chlorine is breaking. This because carbon can only form 4 bonds, and therefore the bond with chlorine has to break. As we can see in the end state, the bond between hydroxide and carbon is formed while the bond between carbon and chlorine is broken, and in the process, chlorine has taken with it 2 electrons that were previously shared with carbon. Since chlorine has taken with it the pair of electrons, is now a chloride ion. Also, as a result of chlorine detaching, the geometry and bonds underwent an inversion, from pointing left at the start to pointing right in the end. Now let's see the chemical reaction again with all elements and compounds as shown in a textbook. In this example, in addition to carbon, chlorine and hydroxide, we can now see the methyl group, hydrogen and the ethyl group. There are two key points to understand here, and these are: hydroxide moves towards the carbon to form a bond, and at the same time, chlorine moves away from carbon and the bond breaks. Also, the geometry undergoes an inversion, as the position of the ethyl group, hydrogen and methyl group changes, from pointing left at the beginning to pointing right in the end. A good analogy will be an umbrella turning inside out. In conclusion, SN2 reaction is characterized by a nucleophile such as hydroxide forming a bond with carbon, and simultaneously the bond between carbon and an halogen such as chloride breaks. And also the geometry undergoes an inversion, shifting from the left to the right.